Hello everyone, my name is Shiva. I'm part of the DevOps practice team at VirtusaPolaris. Today, I'm going to walk you through a short demo to showcase the continuous integration and continuous deployment pipeline. We will use a sample Java-based application which is hosted on a Tomcat server. We will show you how a change made by the developer to the application's source code flows through various functional areas like build, unit test, static code analysis, functional test, and performance test. Looking at this slide, it has two pipelines, the dev pipeline at the top and the QA pipeline at the bottom. The dev pipeline is a Windows machine hosted on AWS Cloud. The QA pipeline is an Ubuntu machine which is also hosted on AWS Cloud. In this demo, we are using widely used industry standard tools like Jira for change management, Jenkins for continuous integration and continuous deployment, Git or GitHub for version control of your source code, JUnit is used for unit testing, SonarQube for code quality, Selenium for functional testing, JMeter is used for performance testing. Docker is the lightweight application container. Tomcat, as we know, is a pure Java HTTP web server. AWS is the cloud infrastructure that hosts this demo environment, and Maven is used for build. The dev pipeline is considered to be very unstable. There are frequent changes made by the development team to the source code, to the config files. They add new libraries, they will patch their server, and that's the reason why the build artifacts created in the dev environment goes through a lot of tests. This is the shift left concept, where the application changes go through a lot of unit tests followed by static code analysis and smoke test to detect any regression caused by the new changes much early in the life cycle. It is less expensive to detect and correct issues in the dev pipeline rather than detecting it in the downstream environments like, say, SIT or production. Once all the tests have passed, what comes out of the dev pipeline is a release-ready software. The software here is a WAR file which can be deployed to various downstream environments like QA, SIT, UAT, demo, staging, and finally to production. For the demo purpose, we will stick with two pipelines, the dev and QA. As you can see at the top left, the developer begins to modify the source code once they have a defect assigned to them. The defect is recorded in Jira, which is the change management tool that we use here. And once the source code changes are checked into the GitHub central repository, Jenkins, which keeps polling, will detect the change automatically. Jenkins will then invoke Maven to compile the source code, and once the source code compilation is successful, it will perform the unit tests followed by the static code analysis. Once these tests pass, a WAR file is created which is then deployed onto the Tomcat server automatically. Selenium is invoked by Jenkins to execute the functional test suites followed by execution of performance test suites of JMeter. In the QA pipeline, the WAR file that comes from the dev pipeline is bundled along with the Tomcat server application into a Docker image. The Docker image is then deployed as a container to bring up the web server application on the Ubuntu machine. Functional and performance tests are executed against this new web server to verify if the application behavior is as expected. So let's quickly walk through the demo. We will see how the live environment looks like. So I've remote logged into the Windows machine. This is my dev pipeline. Let's take a look at the application. This is the sample Java based application which is named as Counter Web App. It has a message, warm welcome to DevOps World practice team. It's also got a link to a servlet. If you click on this servlet, you will see that there's a counter value that increments by 2 every time I click on the link servlet. It also has a link to an external site which, if you click, will take me to a new page and land on the VirtusaPolaris website. We have a similar application in the QA pipeline, which is hosted on the Ubuntu machine, the same application with the same message. You click onto a servlet, it has a counter value that increments by 2 here as well. So let's quickly see how we can make change to the source code and reflect that change to this application in the dev environment and the QA environment. So before I do that, I will have to create an issue and assign it to myself. Let me take a look if I have any issue that's assigned to me. I don't have any, so I need to create one. I'll go about creating an issue, give a very short synopsis describing what the issue is. Here I'm trying to modify the welcome message. I will assign this defect to myself, and once it's assigned, I will say create for Jira to create a new record. CD35 is the defect number. This is a new record that's created. I will have to start working on this defect, so I click on in progress, change the status of the defect to in progress so that I let the team know that I'm working on this issue. We'll be modifying the source code to resolve this issue. So to modify the source code, I open my integrated development environment, which is Eclipse, and I've cloned the repository here. I will have to pull to get the latest changes from the developers. There is nothing to update, everything looks good. So now I can modify the source code that will change the welcome message. This is how my project structure looks like. I need to modify the file sample.jsp which has the welcome message. So I'm going to remove team and have this change reflected back to the GitHub repository. I will save this file. The moment I save, Eclipse says there is a file that's changed. Do you want to commit this change to GitHub repository? I'll say yes. I need to drag it and move it to the staging area and let Git know that this is the file that needs to go to the central repository. Commit message, I will give the Jira defect number to ensure that the change that I made here to the file is traced to the defect number in Jira. Once I verified that, I will commit and push. The changes now move to the central repository. Jenkins, which is polling, will detect the change automatically as soon as this change is reflected in the central repository, and it will kick off a dev pipeline build. Let's take a look at the Jenkins pipeline view. If you notice, there are two pipelines, the dev pipeline and the QA pipeline. Dev pipeline will compile the source code and perform unit test, static code analysis, deployment to Tomcat server, followed by functional test and performance test. In a short while, the build will begin. There you see the dev pipeline build has started. While this build is going on, you can also take a look at the build logs dynamically. The build number is 82. So if you take a look, the build number 82 is running. You can click on that, get a verbose output of what the build is actually doing and the steps that have been followed. Right now, if you see, it says JMeter performance test is running. Once it's done, it says everything is successful. It's triggering a new downstream build, which is the QA pipeline. So if you take a look at the pipeline view, the QA build should begin in a moment. It's started. The QA build now will bundle the WAR file that comes out of the dev pipeline along with the Tomcat web server application into a new Docker image, which is deployed as a container, followed by functional test and performance test. Both of them have completed successfully, which means they've passed all the test suites. We will now take a look at the application to see if those changes that we made is reflected here. So if I refresh this dev pipelines application, you see that the team is removed, which is exactly what we did to the source code. You click on the links and you notice that no change in behavior. So the source code that I've checked in has caused no regression to the change in the application. The same is the case with the QA pipeline. The team is removed. I'll click on servlet to see if there are any unusual behaviors. There are none, so they both look good, and the change I made is reflected in both the dev and the QA pipeline. I can take a look at various metrics from the Jenkins dashboard itself. If you see here, this will tell me how the changes by the development team that's kicked off as a new build has been performing over a period of, let's say, 2 months. If you notice, the build that high triggered has caused no issue to the performance, but there is a build number 30 where the changes that came in caused some unusual behavior to the application's performance. And that was then and there corrected by the development team, and they ensured that the subsequent builds did not cause any issue to the performance. You can also take a look at various other tests like the unit test, how many are passed, how many are failed, how many were skipped. You can take a look at the functional test report, Selenium report. You click on this HTML and you will find detailed report of what all functional tests were performed. You can take a look at the response of your application on the dev environment or the QA environment, the average time, the median, and what were the HTTP codes that were returned by JMeter. You can also take a look at SonarQube static code analysis. You click on this project and it will show you, it will give you a lot of metrics that's very important for the development team. These are the early feedbacks that the development team gets on their project's source code, and it will give you leading indicators like how many minor issues are there with your software source code, and how much time it needs to correct that. It's a guesstimate. It says 13 minutes to correct 5 minor issues. It will also show you the number of unit tests that are passed. Here it says 100% of unit tests are passed. How many failed, how many tests were executed, and so on. It will give you indicators like cyclomatic complexity. It indicates the number of paths through the code. You could set rules to fail the build if the cyclomatic complexity is, say, greater than 10, or if you have major issues, you don't pass the build, you just fail the build and let the development team know about it. It also gives you about the structure of your project, the number of lines of code, how many files does this project have, the functions, the classes, how many directories, and how many lines of code. Once you are done analyzing this report and everything looks good, you can go back to Jira and say I'm done with this change so that I can start working on the new change. But before I do that, I will have to sync up Jira with GitHub repository so that the changes that we introduced in GitHub is reflected back to Jira. This is automated and this happens every half an hour, but because we're short of time for this demo, we will manually sync up the GitHub repository with Jira. Now if I come back and take a look at my issue, I will notice that there is a comment added by Jenkins automatically to this issue. It says continuous deployment executed successfully. This gives me as a developer the confidence which indicates that all the tests have, this change has passed through various pipelines and it has gone through all the tests and successfully it has caused no regression whatsoever. There is one commit, so I can from this dashboard, Jira dashboard view, see what was the file that was modified to resolve this issue. So it says there's one file sample.jsp and the change practice team was changed to practice. I removed team. So that's it, I'm done. I'm fairly confident that this issue can be resolved because it's gone through all the tests, and once I click on done, the status of this defect changes to done and I can start working on other issues that's assigned to me. So that's it with the demo. To summarize, what we've done is we had a defect created in Jira that's assigned to the developer. I modified the source code that was cloned from GitHub, committed the change back to GitHub Central Repository. Jenkins, which was continuously polling, detected the change and kicked off the Maven build. The Maven build successful, followed by JUnit test, SonarQube quality code analysis, and the war file is created, which is then deployed to the Tomcat server. Jenkins will kick off the functional test, Selenium suite, and the performance test of JMeter. And what comes out is a war file that's very stable, cost no regression. This war file is then bundled along with the Tomcat web application into a Docker image. The Docker image is deployed as a container, and the new web service that's sprung up on the Ubuntu machine goes through the functional test of Selenium as well as performance test of JMeter. That's it with the demo. Thank you for your time. Hope you have enjoyed this session. For any queries you may have, you can always reach us. We will be more than happy to help you with queries on DevOps and its related functional areas like continuous integration or continuous deployment. Thank you. Bye-bye.